Hello everyone, I'm Wang Rongzhang. I am currently a professor at the Department of Electronic Engineering in Southern Taiwan University of Science and Technologies. Today, I'm going to introduce an artificial intelligence medicine recognition and verification system, which can be used in hospital dispensing room. We call MedHelper. Here are the unmet needs and the motivations of this project. As you can see, from Taiwan Patient Safety Reporting System, TPR, in 2020, according to the statistics, in the notification of adverse events in hospitals, there are a total nearly 27,000 events related to drug. Drug events accounted for the first place among all the adverse events notifications in hospitals. Among these adverse drug events, 25% were caused by incorrect drug dispensations. In Taiwan, for example, in Kaohsiung Medical University Zhonghe Memorial Hospital, which is a medical center, the occurrence rate of drug dispensation errors is 0.0041%. In Liuyin Qimei Hospitals, which is a teaching hospital, the occurrence rate of drug dispensation rate is 0.034%. Finally, in Yanchao Jinghe Hospitals, which is a non-teaching hospital, the occurrence rate of drug dispensation error is increases to 0.54%. Here shows the current medicine dispensation flow in the hospital dispensation room. After the doctor issues the prescriptions in the clinic, in the dispensation room, the parents first confirms the prescriptions and then starts to dispense the drugs. After the drug dispensation is completed, a confirmation of whether the drug dispensation is wrong will be checked. In the medical centers, for example, in Kaohsiung Medical University Zhonghe Memorial Hospitals, another premise will do a check of the medicines before they are delivered to the pharmacies. This is why from such statistics it can be found that the larger scale of the hospital can achieve a lower probabilities of drug dispensation errors. In order to resolve the medicine dispensation errors events in hospitals, we propose a system called MedHelper, which consists of a recognition systems and a training systems. The recognition systems includes a display module, a QR code reader, a camera modules, and a NVIDIA Severe modules. It uses AI technologies to identify the medicines in the medicine bag. The training system is composed of a camera modules, a rotating platform, and a network models. The goal of the training subsystem is to take the image sample of the drug. Here is a description of how to use the training systems. First, the medicine bag containing the medicine is placed on the rotating platform, and the software on the computer controls the rotation of the rotating platform and then takes pictures. After marking the features of the drug image, we put the labeled drug image samples into the AI server for further training. In using the recognition subsystem to identify the dispatched drugs, the medicine bag containing the medicine is placed on the transparent platform of the AI drug recognition device. And then the drug identification result will be displayed on the screen and transmitted to the management platform for further statistics. In this slide, we are going to discuss the hardware implementation issues of MedHelper. Since the accuracy of AI recognitions will be affected by various sampling, key factors such as surrounding light source, the size of the object, the position of the object, the angle of the object, and so on. In order to overcome these issues in MedHelper, the designs of the sampling and recognition devices have the following same settings. First, the distance D1, that is the distance from the camera to the sample drug in image drug sampling device, and the distance D2, that is the distance from the camera to the recognized drug in AI drug recognition device are the same. Second, we use the same surround light source in the image drug sampling and AI drug recognition devices. These same design considerations can effectively improve the accuracy of drug identifications. Another issue that affects the accuracy of the drug identifications is similarity of drugs. For examples, as you can see, it can be found in this table that the drug D and E have lower recall values of AI recognitions. This is because the characteristics of these two drugs are too similar, which will increase the false recognition rate. To resolve these problems, we try to assign drugs with similar characteristics to different training groups to improve the recognition accuracy. So as you can see in these two tables, when drugs D and E are assigned to different groups, the identification accuracy of the two drugs can be increased to 100%. So to achieve this, the AI drug recognition device uses our proposed hierarchical multi-model AI drug recognition technologies, which consists of multiple AI models, and each AI models used to recognize the drug within the same group. So we implement a software layer called Dispatcher to dispatch the drug image to its dedicated container for further recognition purpose. And up to now, we have successfully identified 6 package types of drug. For example, such as bulk, the box, aluminum, packet, can, slave, and drip, as well as identify more than 300 drugs. The response time for the AI drug recognition is around 0.5 seconds. The AI response time is less than the time of the current dispensers to identify drugs with their eyes. So this slide shows the situations of discussions with the dispatchers in the hospital's dispatch room during the research and development process. And the photos on the right-hand side is the MedHelper, which is showed at the Taiwan Healthcare exhibitions in 2020. And here is the conclusions of our proposals. In the current drug dispensing flow, after the drug dispensing is completed, a confirmation of whether the drug dispensing is wrong will be checked by a parameter. This will cause a high dispensing error rate, and the parameter needs 3 seconds to check the drug once time in average. The most important problem is that in small and medium-sized hospitals, there are no parameters for drug recheck in the dispensing room. So our MedHelper can overcome these issues. Since the drug recheck is done by AI drug recognition device with only around 0.5 seconds for one drug recheck, so it can be suitable for use in hospitals' dispensing room to effectively reduce the error rate of drug dispensations. And this is the end of my presentations. We hope you can use the AI drug recognitions. You can reduce the error drug dispensations. This is my presentation. Thanks for your attention.